Hello, this is Form 5, Chapter 3, Thermochemistry. This is the second time I'm trying to record this. I hope it actually records. So thermochemistry, is heat. Chemistry is chemistry lah. Okay, so heat is a form of energy, so it's measured in joules. Okay, so all chemical reactions involves heat, and heat can be absorbed or even released. There's two types of chemical reactions. There's endothermic and exothermic. So endo macam enter, kalau exo exit, heat goes out. So sample question here. Number is from 25 degrees to 70 degrees. So the temperature actually increases because there's more presence of energy kan. So bila there's more heat energy released to the surrounding, which is in this case it's the solution. Maksudnya exothermic has happened, so the temperature increases. Okay, so kita contoh kat sini, endothermic dia absorb heat from the surrounding, so from 100 joule ni dia jadi 40 joule. So when chemical reaction occurs, when chemical reaction dia absorb heat from the surrounding, what happens is endothermic happens, and the solution will lose energy because it's absorbing heat. The particle yang ni, the chemical reaction ni, they absorb heat. So solution inside the beaker ni will lose energy. So bila dia lose energy, temperature of the solution will drop. So same thing here. When chemical reaction is release heat to surrounding, the solution itself will gain energy, and the temperature of the solution will eventually increase. So from 100 joule to 150 joules. So let's take a look at the examples of endothermic and exothermic reactions. Now exothermic, there's a lot of things, okay? So we're gonna hafal only the endothermic one. So some of it includes photosynthesis, dissolving nitrate salt, dissolving ammonium salt, decomposition of carbonate and nitrate, reaction that involves hydrogen carbonate, so HCO3. A sort of side note, decomposition, it breaks the compound using heat. So clearly it's absorbing heat to eventually break the compound. So carbonate can decompose into carbon dioxide, whereas nitrate decompose into nitrogen dioxide and also oxygen. And the color of nitrogen dioxide, if I'm not mistaken, is brown. Okay, so decomposition of nitrates and carbonates, dissolve of nitrate salt and ammonium salt. Okay, so now we're just gonna go next. So hot and cold pack, we just need to take note. Now whenever it's hot pack, we're dealing with magnesium sulfate, whereas cold pack, we're dealing with ammonium nitrate. And this is something you must know, magnesium sulfate. How to have also, I'm not sure. You have to create your own acronyms or something. So when solid turns to gas, it absorbs heat, breaking the bond. Okay, so gas, when it goes to solid, sublimation, process called sublimation, but anywho, it's releasing heat to form the bond. Okay, so all heat that's absorbed or released during chemical reaction, there's also heat change of reaction symbol. When they do, that is called a thermochemical equation. So it can be chemical equation, ionic equation, but the minute they show the heat change, then it's called thermochemical equation. For example, this is a chemical equation, right? But it becomes a thermochemical equation when it shows this the sign over here, the heat change. And negative means it's actually releasing heat, and it's per mole. See, it's releasing 57.3 kilojoules. Okay, so referring the sign, if it's positive, endothermic, so it's absorbing heat. Exothermic is releasing heat, so it's negative. Okay, so as I mentioned just now, so there's two important diagrams that you have to know how to sort of interpret in this chapter. Number one is energy level diagrams. Number two is energy profile diagram. So energy level diagram, you can determine whether it's exothermic or endothermic, how much heat is released or absorbed, and the total energy content of reactants and products. For example, if you encounter this question. But before that, I'm going to find out how to draw it in the first place. First, you need to draw a y-axis. There's no x-axis, but you need to draw a horizontal line. And if it is absorbing heat, so it's positive, it goes up. Okay, then go straight. If it's releasing heat, it goes down. Because this is showing the heat energy change. Goes down, negative, the arrow, and then straight line. So you're going to just your reactants and products. Your reactants, you're going to put it here. Your product, you're going to put it here. And the heat change, you're going to put it like sebelah the arrow. Same thing over here. Sebelah the arrow is positive, so it's going up. Product, and then here you're going to have to put your reactants. Okay, so same thing here. This is how to interpret the information. So as you can see, 1 mole of magnesium reacts with 1 mole of copper sulfate to form 1 mole of magnesium sulfate and 1 mole of copper. And then later, tengok dia release sebab dia negative. 467 kilojoules of heat is released to the surrounding. So when that happens, we can say the total energy content for the product is lower than the total energy content of the reactants. Or you can say total energy of the content of the reactants is more than total energy content of the product. Here you can also interpret it that way. Same thing here. So it doesn't have to be a chemical equation. It can be an ionic equation as well. It can be a half equation. So in this case, there's no negative. So this is a ionic equation. Okay, so it doesn't have to be a chemical equation. Write it the same way, your reactants, as well as your products, and then the heat change over here. So as you guys can see, 1 mole of calcium ion, calcium 2 plus ion E, they react with 2 mole of chloride ion. It will produce 1 mole of calcium chloride, and 150 kilojoules is absorbed. Okay, so then you can say whether it's endothermic or exothermic reaction. So bila dia absorb is obviously an endothermic reaction. Then you're going to determine which part yang ada higher or lower energy content level. So total energy content of the, in this case, of the product is more than the reactant. So this is where we jumpa energy profile diagram. So we have energy level diagram and energy profile diagram. Profile is like P, so there's like a peak. So nampak tak dia ada curve upwards, macam tu. It's always curving upwards. You don't need to memorize. You can just modify it from the energy level diagrams. So for example, if it's going down, selalunya dia go down macam tu kan, straight line go down and right. But instead of like that, you just put a curve upwards and go down. It's always curving upwards, okay. Nak pergi atas pun, instead of like going arrow atas, you go atas and curve. Okay, so that is about it. Okay, so all chemical reactions, there are 2 steps. There are the reactants that will absorb the energy to break the bonds, and there are also products that release energy to form the bonds. Okay, so bond energy can be used to calculate the heat change. And how are we going to do that? We're going to do the energy, total energy to break the bond minus the total energy to form the bond. And when you break the bond is when you absorb energy. When you form the bond is when you release energy. So sometimes soalan boleh macam ni. Soalan boleh keluar macam ni. Use the bond energy to calculate heat of reaction. So the heat change for the reaction is as below. So let's see. So here we have hydrogen plus chlorine equals to hydrochloric acid. So nampak tak? Hydrogen ni dia ada bond between hydrogen and hydrogen. So it must be 436 plus. And ni chlorine and chlorine also. So 243. That's the left side. Okay, this to break the bond is 7679. To form the bond HCl, we thought the ratio dia ada 2. So you times 2. Okay, so to break the bond minus form the bond, nampak tak negative? Negative means releasing heat. Dia undergo exothermic kat sini. Next soalan. Nampak tak? So yang ni carbon react with the oxygen. Carbon ni tak ada bond. Okay, there's 0 bond. So we're not going to count that. But if you see the oxygen, there's 2 bonds there. So we just tengok soalan. Diagram is 495. So add 495. Then later the carbon dioxide. So kita ada carbon dioxide and the bond is like this, right? So this means C dengan O ni bond dia akan jadi macam 740 times 2. So there's technically 2. Alright? So when there's 2, you just times 2. Then you just minus. So it's negative, so it's releasing heat. So it's exothermic reaction. So how to analyze every profile diagram? So the gap between the reactants to the peak is the highest point. What does that mean? The reactant to the peak. The reactant left side to the peak, that's the activation energy. Okay? But then kalau the energy change is from the product to the reactant. Okay, yeah, we're doing the staircase basically. This is the staircase kind. So this is the heat change. Total energy to form the bond, however, you don't take the peak to the product because product kan macam indicate to form the bond. Total energy that is released to form the bond. Okay, so again, macam ni, activation energy is from the reactants to the peak. So that's the activation energy. Heat change is from the distance between the two tangga. And then the energy released to form the bond is the product punya peak until the line of the product. To absorb to break energy absorbed to break the bond is from the reactants line to the peak. Okay, so activation energy, tengok the reactant to the peak. Heat change is the staircase difference. Heat release is the peak until the product. So super easy so far. And okay, let's tengok the soalan. Which statement is correct regarding exothermic? Now this question might be a bit tricky, but like, okay, think about it. Exothermic is releasing heat. So to say no heat is absorbed or released is wrong. So confirm D is up. And later, now A. The heat absorbed during bond breaking is more than the heat absorbed during bond formation. Okay, first we need to analyze. We can use two methods. First, we can use diagram visualization method. So exothermic is releasing heat. Bila dia releasing heat, maksudnya dia akan lose energy, right? So dia akan go down. So you can draw it like this. Okay, energy profile diagram ni. So nampak tak? So using the visualization method, heat energy absorbed to break the bonds. You're going to see the reactants to the peak, right? So is that tapi kalau releasing to form the bond from peak until product. So as you can see, absorb je sikit je by dengan release. So it must be less. See? Absorb during breaking bond is less, so it's B. Okay, tapi kalau, remember kalau activation energy is from the reactants to the peak, heat change is from the difference of staircase, release is the peak until the product. Okay, tapi kalau tak nak guna visualization method and you just use the logic maths method. So, bila exothermic, dia kena lah negative, right? Bila negative, dia kena small number minus big number, right? And bila dia small number and big number, meaning to say that the breaking energy to break the bond is way smaller than the energy to form the bond. So that, I mean, that's the logic of it. So then you know it's B. So that's about it for the part 1 of this chapter. Ta-da! And by the way, my voice is like, I'm losing my voice. But you know what? It's okay. I still want to make this video. Yeah, that's it. Bye!